In this video, we're going to see how to simplify radicals. So if we didn't have a calculator, like we could estimate what the square root of 20 approximately will be, but a lot of times it's kind of like simplifying fractions. It's something we want to try to reduce as much as possible. So basically the way we do that is we kind of make a factor tree. We say square root of 20, like what is that really like? So square root of 20 is kind of like 5 times 4. So square root of 20 can be rewritten as 5, square root of 5 times the square root of 4. And then as soon as you recognize any square roots that you know the answer to, you can pull them out. So the square root of 4 we know is 2. So I'm going to turn that into a 2, whereas the square root of 5 is going to maintain as the square root of 5. And 5 can't be factored any further. It's just 5 and 1. So at this point we're done. So we would say this is 2 square roots of 5. And that's as reduced as it's going to get. Your goal is to try to factor it into perfect squares, 1, 4, 9, 16, 25 if you can. I could have broken 20 into 2 and 10, but then it becomes a little trickier. It's easier if I can just do this right away. So here's another one, 480. So let's say I recognize that it's divisible by 4. It's actually, you can break it better than that, but let's just say, okay, square root of 4 times the square root of 120. Okay, so now I can say, oh, square root of 4 is 2, so I can transform that into a 2, and I still have the square root of 120, so maybe I break it again into the square root of 4 and the square root of 30. So now I still have this 2 here, this square root of 4 can become a 2, and then I say, okay, the square root of 30, I could break that into the square root of 6 and the square root of 5, if I like. And 2 times 2 is 4, so I can combine those. Now the square root of 6, I can combine in the square root of 3 and the square root of 2, and then I still have the square root of 5. Now here's the issue. None of these are perfect squares, and it's as simplified as I can get. So basically, I'm going to kind of have to go back to scratch and leave it as the square root of 30. So I'm going to say, all right, I had 4 square roots of 30, and that's really as good as it's going to get here. All right, so we get this last one, square root of 216, so I might recognize that I can put a 3 into that. So if I put square root of 3, and then I would get the square root of 72, because 3 goes into 21 7 times and 6 twice. So, okay, I'll leave the square root of 3 alone. And then I say 72, okay, I can put 3 into that as well. So square root of 3, and 3 goes into 7 twice. Carry that over, I get square root of 24. And then I can look at square root of 3 times the square root of 3 is really the square root of 9, which is 3. So when you combine two of the same, you get that number. So the square root of 3 times the square root of 3 is by definition 3. Now the square root of 24 I can break up into the square root of 4 and the square root of 6. Once again, the square root of 4 I can call 2. So 3 times 2 times the square root of 6. 3 times 2 is 6, so I have 6 times the square root of 6. And just to check, 6 can be broken up into the square root of 3 and the square root of 2, but I can't really do anything with either of those, so I'm just going to leave this as 6 square roots of 6. So it's a little tricky, you have to really think through and divide it up and make sure you keep carrying whatever you have here down throughout the problem. Like, don't leave numbers behind, just keep bringing them through. And when you're done, it doesn't hurt to sort of check this over if you want. So if we say, okay, 6 squared is 36, I can place it back in there and see that 36 times 6 is 216. 4 squared is 16, so 16 times 30, does that equal 480? It does. 2, if I put it back under, I have to square it, so it would be square root of 5 times square root of 4, which is what I had up here. So if you want to try to check that. So this is a little tricky. Take some practice, so I encourage you to do a lot of practice with it until you have a better understanding. So until next time, I am Derek Genova. Have a delightful day.